Welcome to another episode, a 33rd episode of Ideas and Lives. I'm Bob Lerman, a social policy economist, and we have Zvi Bodhi.
Hi,
Zvi
I'm a
Bodhi.
financial economist.
Okay, and today I'm really thrilled that we have an old friend and colleague, Bill Raduchel, who has certainly a very interesting career and compelling ideas. So welcome, Bill Raduchel.
Welcome. Thank you. Glad to be here.
Bill has been an economist, a top corporate official on many boards. He's knowledgeable about tech, has a new book coming out. And so we're going to get started by looking at kind of the arc of your career, Bill. So why don't you start with where you grew up and what your early family like, parents, siblings?
Well, I grew up in Houghton, Michigan. Houghton is in the middle of what's called the Copper Country. And in 1910, that county was the richest county in America. It was Santa Clara County 2000.
Wow.
And it was all from copper. And the copper, which makes up the wire in New York City and Chicago and Los Angeles, all over the country, when we put in electricity and telephone wires, came from there. And it boomed. The county was 250,000 people. It's now 30,000. It was number one economically. It's now probably 3,200 out of whatever there are, 3,300 counties. So I've been watching decline my entire life.
Oh my goodness.
There was a strike 110 years ago. It ended, unfortunately, in the death of 73 children in a Christmas fire. And the town never really recovered from that. And the mines closed completely in the Depression. And so it's been declining all the way along the line. There is a college in town, Michigan Technological University, and Michigan Tech was originally founded as the Michigan College of Mines to train mining engineers to go into the mines. And it still has a mining degree, which suddenly has become very valuable and very profitable, or demanded, because suddenly we need people to do mining because electric cars require mining. And we don't have enough miners. So that keeps the town alive, as do people retiring there with their pensions and Social Security, because the cost of living is very low. So it was there was my high school class. I'm going back next week to my 60th high school reunion. There's still about 30 of us left. It was a small class. The class was about 60, 65. It was very good. My father died when I was young and there was no money, so I decided to try to get through college quickly, and so I transferred in the end from Michigan Tech to Michigan State. I was originally going to be a chemical engineer, and I talk to college kids today and I'm just stunned at the workload they have, because my sophomore year, I went to class 43 hours a week, not homework, 43 hours a week in class.
Wow.
And homework. And today they look at me and think that's a monthly number, not a weekly number. But that it's interesting.
So when you went to Michigan State, what year was it? Your junior year? Or?
Well, you will remember that the country, when Sputnik went up, decided that national intelligence, national security required that we be educated in the sciences. And so when the Defense Education Act was passed, my high school, like every high school, basically took the smarter kids in the class and pushed us up a year in STEM. So by the time I got to the end of my junior year, I only had one class in English left to graduation, but the school board wouldn't waive it. So the senior year in high school, I went full-time to Michigan Tech and came back once for an hour for the English class. But that meant that by the time I graduated from high school, I already had a lot of college credits. I then took the 43 hours a week of being, and that was not an unusual load. I mean, I was going to be a chemical engineer, and the load was that heavy at Tech. And I met an economist, my professor, Ken Alexander, and he got me inspired. It's interesting, chemistry and economics are very similar. They're both equilibrium sciences. Chemistry is all about equilibrium, and economics is all about equilibrium. And that meant that it was an easy transition. And I went to Michigan State, and I could graduate there in a year. And I did. And then I went to Harvard for graduate study. And then at Harvard, I was an economist, a statistician, and the software was terrible. And I knew computers from a science seminar I went to as a sophomore in high school. And
Wow,
so,
they had computers in high school? And
well, no, not. I mean, the first computer I saw, Bob, was a computer that fired Nike anti-aircraft missiles at Russian bombers. And it was a huge computer, the size of a warehouse, made with vacuum tubes. The staff sergeant showing it to us, a bunch of high school kids, had it play music and flash flags. But I was impressed. And then we got our hands on an IBM 1620, which is the first ever transistor computer. And we were allowed at 15 to program it. And so, when I went back to Tech, I had to go back to a Bendix G15, which was an earlier was not as good as the 1620. They got a 1620 soon after. The Bendix machine only had a paper tape reader and a bell. So when you programmed it, you had to learn how to read paper tape and read what it was, or it would take too long to put it back to the flex writer. And you'd also use bell sequences. And so you'd sit there and you'd have ding, 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 and you'd have to remember what you programmed that for, but the programs weren't very complicated.
so by the time you got to Harvard, you already had a considerable amount of programming capability.
Yeah, but I didn't know computer science. I knew how to write Fortran. And I could do some things.
Well, that was enough to help Sam Ray and me with our
well, I did it. I invented a lot of computer science to write score. I mean, that's when I learned computer science, and that because it had a virtual machine in it. I had to write a compiler. I had to teach myself most of computer science in order to make that program and make it work.
Well, this is so for our listeners, a friend of ours, unfortunately, who passed away, Sam Ray, and I were doing a big project with current population survey data. At the time, it was a very big data set. Now it's nothing. But Bill was there to help us with the programming, and we certainly couldn't do it. So thank you again for all your help on that.
It was the only program that could process 1 million records at the time for anything approaching a reasonable cost. And the trick to it was actually pretty simple, but great ideas are usually simple. And that was that I stored each observation when it was a binary, when it was a dummy variable, as just 1 bit. And the competing program stored it as a floating point 1 or 0. Well, the difference between that is enormous. And then processing, they used to multiply the 1s and 0s. Well, you don't have to multiply 1s and 0s. You can use Boolean logic on them. So that's what made the program work. But that's what taught me. There were a lot of obstacles, but that's what got me into computer science and understanding that computer science.
You were mainly taking economics and what you at graduate school, now we're talking at Harvard, and you were focusing on econometrics, or what?
Yeah, econometrics, and then development models. I mean, my thesis was building a general equilibrium model. And what I did, which people weren't doing, is everybody else was using linear programming, and I did nonlinear. And I introduced a labor market, and I introduced a bond market. And what the thesis showed was that all the partial equilibrium results were just completely wrong. That if you don't look at all the markets interacting, you get the wrong answers. There's one thing
Was
that,
anybody else doing, this is something I'm sure is
no,
interesting to Tzvi, are the others using the financial markets embedded in your?
they were all doing linear programming. And I mean, yeah, there was
What year was this?
this would be 72, 71, 70. And I mean, it was bespoke. I was writing all this software myself to go do it because there were no packages that let you do it. I mean, I'm a great believer in what John Tukey said, which is that, far better a vague answer to the right question than a precise answer to the wrong question, because you can always ask the wrong question in such a way as to let you get as precise an answer as you want. And unfortunately, I've learned in life that precise answers drive out vague answers, regardless of the merits of the antecedent questions. And people sit there and they look at it and go, well, the computer says this. And it's the debate I'm still having right now with my doctors. Because I understand.
So anyway, so you did this dissertation and you stayed at Harvard. Is that where you got to know Galbraith?
Well, Galbraith had a large class.
I mean, Galbraith wasn't an econometrician.
No. But I have a
Or a
photograph.
general equilibrium theorist either.
No, but I have a nice photograph out there that he sent me on his 80th birthday that says, to Bill Raduchel, who so ably held my hand. And we had an incredible number of conversations about statistics and technology, because he was very interested in where it was going. But I mean, he was firmly of the belief that the global elite would use technology to accumulate wealth and power. And if any observation has ever been true in my life, it was that one. So I'm published, the book's printed, called The New Technology State, which tries to take a Galbraithian view of the world today. And it's in some ways, it's a dark book, because technology has left us fragile, divided, and unequal. And it didn't mean to. It just
Well, it's unequal, but at a much higher standard in many ways. I mean,
no, and that's the trade-off.
I can
Neoclassical trade-off.
I mean, a regular person with an internet connection can access virtually all the music ever made. And that's available to everybody. A huge amount of literature is available free to
Yeah.
broad scope of people.
But jobs have become much less meaningful and rewarding up and down the scale, because technology has taken the.
Well, that's an interesting point. I'll be interested in reading your book. But anyway, so you got to know Galbraith, and
But he had this large class, and he needed people to grade the papers. And so Bill Buchner, who you know, my roommate at the time, knew the head program, and he got into it. That got me into being a grader. I got to know Galbraith, and I became the replacement. And I ended up teaching his class with him. I actually used to do a couple of lectures in the course of a semester. And so I just spent a lot of time with him. And then he would use me to read the books and comment on where the technology or the statistics and things were there. So I spent a lot of time with him for 5 years.
and then after grad school, you stayed at Harvard for a while.
Yeah, I was, I don't know, I was having a good time. I was assistant professor for 5 years. And then I stayed on as a lecturer. And then I was also eventually assistant dean of admissions and financial aids. So for 5 years, I ended up doing all the data processing and statistics for Harvard and originally Radcliffe admissions. And then I did the statistics for the merger of male and female admissions. So that was an interesting time. It was a totally interesting job, totally different job than anything else. I mean,
Yeah, wow, that's very different.
taught me a lot about how to work as a team of people, because it was a team effort to do the admissions process. And I wrote a paper on it, and I submitted it to Harvard Magazine, and Harvard Magazine accepted it, and they had editorial independence, and they promised that. And then I got a phone call from Henry Rosofsky, who was then the dean of the faculty, and he said, "I just read your paper." So it wasn't quite editorial independence, and he said, "It's a great paper. It's completely accurate, easy to read, but can I ask you as a personal favor to withdraw it?" So I did, but it's in the book. And because that was 1978, that's a long time ago.
Well,
It's still be
yeah, they've now had to have court cases get information from admissions offices. So,
well, it's the process hasn't changed that much. I mean, my friend still, is still the dean. So it's still probably very much the same way, but it's an impossible challenge. I mean, you have to start with 10 times, or we got 15 times, I think, as many people as you can take. So how do you get down from on a 15-to-1 basis? And it's a hard, difficult job.
yeah. So then what happened right after
Well,
Harvard employment?
Well, you see, Harvard didn't think much of software. I got a phone call prior to the vote on whether I'd be promoted or not. And the call was from Jim Dusenberry, who was the chairman of the economics department. And he said, "We just had a meeting and discussed whether software should be included in evaluating your intellectual work. And we concluded that software had no intellectual value, and that you and your software were like a glass blower to a chemist. And therefore, we were not going to consider any of those things as being a contribution to intellectual value." And I knew then that the chances of being promoted were probably pretty low, even though everybody was using my software, and without it, they couldn't do what they were doing. But that was that. And then there was an assistant dean of the faculty who thought that software and people should be paid minimum wage. And I decided in that environment that I would leave, and I went to the Institute for Defense Analyses. And then from there, I went to Data Resources, which spun out of the Harvard Economics Department. And then from there, I went to Data Resources in Lexington, and from there to McGraw Hill. And
So tell us about how long were you at Data Resources?
78 until 83, 5 years.
So you were doing econometric models and
No, I was doing software.
software, mainly software.
But I mean, it was software for economists. And so therefore, understanding economics, I mean, most of my life, I have ended up being what I think people call a deep generalist. They're better software people than me. They're better economists than me, but there's probably not many that would come close in understanding as much about both subjects as I. And that was the strength, is that I could talk to both sides of the party.
So you stayed with Data Resources.
Well,
McGraw
then
Hill
Data
took them
Resources
over.
was acquired by McGraw Hill.
Okay. How did that change your position?
Well, when I went to corporate, I became the youngest senior VP in the history of McGraw Hill.
Senior VP for what?
Well, I was senior VP and chief scientist, which is a weird title, but the CEO wanted to transform the company, and he wanted to make it an online distribution company leader. I remember he's 10 years before the invention of the internet. So he had the right idea, but a decade too soon.
Yeah.
And the way to do it and the technology to do it was far more expensive and far more complicated and far more fragile than you could probably ever deploy. But that is what he wanted to do. And he hired 8 people in their 30s to be the young Turks to try to spur the company into change. And we were all gone within 6 months of each other, 3 years later, because the company didn't like the change and spit us out.
Mm-hmm.
They went back to what they knew how to do.
You could have invented Kindle, I guess.
well,
Is that the direction he wanted to go?
No. We were worried more about financial data. You gotta remember, I mean, until really that time, until 83, 84, they only computed the Dow Jones Industrial Average once a day at the end of the day. And it's only 40 years ago that you were able to compute it in real time and trade on it. And that's because of a company called Monchik Webber, which is founded by Leon Williams, who's also passed. I bought that company from McGraw Hill, and they were the leader in distributing data real time. So they took the stock market data and you could process it in real time. That was completely revolutionary, right? That's where all index trading came from, because you couldn't do that before. All these indices were computed at night. I mean, using in mechanical calculators. I mean, it's very different. It's hard to believe that's only 40 years ago, but that's what it was.
Wow.
The Dow Jones Industrial Average is unweighted and 30 stocks because you couldn't compute it more.
So Tzvi, that's interesting with the financial data.
Yes, and I experienced that same evolution, if you want to call it that. It was in my thesis at MIT.
Because you were trying to get data on inflation, right? Or
yes, rates of return and creating portfolios.
yeah, so that was more complicated then. Let's put
Well, it was pretty. It sounds like it was similar to what Bill experienced, and it was during the 70s.
I mean, you had Monchik Webber was the one company that was delivering information in real time,
the 80s, really.
right? And that was in 1983, 10 years before the internet was even defined. And that was that really did change the world. Because then S&P was able to define. The S&P was this backward company, sort of, but suddenly the S&P 500 became something that people wanted to trade.
Unstable there. So you were at McGraw Hill doing these. I mean, it seems like that would be a financially rewarding piece for McGraw Hill.
Well, they killed it. They decided not to do that. And I said they went back to their old ways, and they could have owned the world on this. But Harold McGraw decided, I think, that it wasn't really what he wanted to do. And the CEO eventually, Harold controlled the board. So they stopped doing most of this stuff. The things that were launched, Eric Herr launched a online trading in oil futures in 1983. Decades before, but it just was too early. And you would have had to take losses, but you would have ended up with incredibly valuable franchises. And that wasn't the way they thought,
Yeah.
And
too short term.
And data resources ended up being more of a chimera than anybody would have thought, because it turned out that what the people really bought wasn't the models and the data. They bought the software. And EPS and DRI gave them personal computing, 15 years before there were personal computers. Not quite, but before they were useful at that level. And so DRI boomed, but it wasn't the models and it wasn't the data. The day I showed up,
what happened to DRI?
It eventually just faded away and got absorbed into S&P and then got sold out. You know, again, it ended up that DRI was a precise answer, but maybe not the right answer. And I mean, economists, you can remember, you know, under the Kennedy years had this halo. And people thought you could run the world. People thought you could forecast. And, you know, eventually you couldn't. I mean, the forecasting models at DRI all included what they called add factors. And add factors basically defined the model would predict a result, and then you'd put in add factors to get the result you thought was right. So, I mean, the forecast was based more on the judgment than it was on the model. It wasn't to say the model wasn't helpful, but it really wasn't just the model. So, but DRI was all funded by people doing computing on their own data and producing charts on their own data. And when you could do that with Lotus 1-2-3, that business just began to decline very quickly.
So then where did you go from?
Well, from there I went to Xerox, and Xerox was another company going through a digital transformation and trying to figure out how to, you know, how to survive in a world they depended on paper. And, you know, the copier revolutionized the office because suddenly information could be disseminated in ways that you never would have thought. The first copier, the 914, was estimated that it would sell 25,000 units worldwide. And the way that the consulting company got to that is they got the volume of carbon paper sold in the world. And they said that 25,000 would replace carbon paper. Well, there was a lot more demand for information than was reflected in carbon paper. They eventually sold 1.4 million. So that was a marketing forecast that was off by, you know, a few hundred times, you know, several orders of magnitude. For a while, the person who was the procurement director for Xerox at that time worked for me, and, you know, until retirement. And he told me the story that he had to call his supplier and get more things. Well, the strategic material in the Xerox 914, you're not going to believe this, but it is true, was Australian rabbit fur. And Australian rabbits have one stiff hair out of every 7. And it turned out that Australian rabbit fur was exactly the right texture to kill the drum, to clean the drum on the copier after you'd made the copy. And it didn't scratch it, but it was stiff enough to get the toner out. So the 914 was designed with Australian rabbit fur as a critical ingredient. So Hap called them up and called up his supplier, probably woke him, and I didn't know time zones, and said he needed some more. And the guy thought that was a good idea, and great, how many did he need? And Hap said 250,000. And when did you need them? And he said, well, next week. And his supplier said, well, we shoot them with a 22, you know, and I don't think there are 250,000 22 shells
Bullets?
in Australia. So Xerox had to find a synthetic substitute.
Were there
But-
22,000 rabbits?
Oh yeah, there's no problem finding 250,000 rabbits, but
Finding enough rabbit.
enough, you know, it wasn't going to work. But I mean, Xerox, you know, it's just a transition that, look, you see Boeing going through it today, you see GM, you see Ford going through it, which is converting an analog company to a digital company is very hard, and may not be possible. I mean, there's a TikTok interview out of the CEO of Ford talking about competing with Tesla. Tesla has one chipset and one software stack in the car. Ford has 150 software stacks from 150 different vendors, and, you know, tens of chipsets. I mean, it's an impossibility. I mean, they, you know, the edge that gives Tesla is just enormous. But it's separate software that controls the windows, and they can't change it. They have to go back to the vendor to change it, or get their permission to change it. And they use different
This
chips.
is Ford or GM has to?
Or GM's the same way.
Yeah.
And they don't, I mean, Boeing hired their first VP of software last year. Only after the 737 MAX disaster. Which is
Wow.
also. So is
Well,
there?
let's get back to Bill Raduchel.
Well, no, but so.
So you're at
it's
Xerox.
the same thing. I mean, it was trying to get them into a, in a digital world. And, I was in many ways the one-eyed man in the eye of the eyes, one-eyed man in the eyes, the land of the blind. And, but I was commuting, I was what today would be called the chief product officer of the Xerox workstation division. And the Xerox workstations were early. They were based on the R&D done at Park, but they were very, very expensive. And the business was losing 100 million a year. Xerox couldn't afford that, but their best customers bought it. And, one thing I learned is that your best customers buy your worst product. And that's always true. And so Xerox couldn't close it down. And my job was to figure out a way to close it down, which I did. But I was flying cross country sometimes 3 times in a week because I had 2 bosses, one in California and one in New York. And I was commuting. And that was too hard. And they didn't respond. And one day I was driving to work and my friend, my former student, drove up alongside of me and said, "You're going to get an offer to work at Sun and you should take it." And, I did. So then I went to Sun Microsystems.
So
I was there the day
for our listeners, tell them what Sun Microsystems was.
Well, Sun Microsystems built engineering workstations, which were very powerful individual desktops. And at the time, they cost more money than a PC, and they were much more powerful than PC. And they took over Wall Street because they were powerful enough to compute the indices in real time. PCs were not. And Sun then became the internet company. We ran an ad that said we put the dot in .com, and that doubled our revenues. And the internet ran on Sun. The internet in 1993 was almost all Sun hardware. The routers, the servers, everything was Sun hardware. And then the internet fueled a boom for Sun. And while I was there until 99, and we grew from 1 to 14 billion in that time. So, I mean, that's experiencing incredibly rapid growth and understanding all the ins and outs. But again, I was making investment decisions, policy decisions. So I became, a jailhouse engineer. I spent a lot of time with the product engineers, learning about computer science and the challenges and the things that were there. And, from there, then we did a deal with AOL, and I met the AOL people. And then AOL offered me a job here in Virginia. And so I came here as the chief technology of AOL.
Well, what happened to Sun?
I left, and then it went from a peak of $213 billion market cap intraday on one day, and it sold for 7 years later. I mean,
why did it? I mean, was it part of just the IT?
I don't.
Scott
and I have talked about it.
Some of it was that.
I mean, there are lots of things. It's hard to figure out exactly which one, but all the workstation businesses faded and went away. And the server businesses, I don't know. I mean, Oracle had to buy it because the only machines that could run Oracle database well were Sun. And so Oracle is still selling Sun servers because that's the best hardware if you want to have an Oracle database. And there's a reason for that, which I can explain, but that's not what you want to discuss on this podcast. But no. It's a, it's an interesting question. I mean, I wasn't there. I was busy. I was doing other things. And
so what were you busy with at AOL Time Warner?
Well, I was hired to figure out what the future in broadband world would be. But then 2 weeks after I got to AOL, Steve decided that we were going to buy Time Warner. And then that became a 2-year diversion. And then Time Warner ended up getting rid of Steve. They ended up dominating the company. And then 6 months after Steve was fired, I was fired. And I learned a lot. Again, they spent tens of millions of dollars educating me on the technology and the media and understanding it. And it's very interesting how media companies react to technology. They're totally dependent on it, but they hate it. And it's true in every media company.
Can you expand on that? What do you mean they depend on it, but they hate it?
Well, they depend on it. I mean, technology is how they get to market. But, it's really comes down to monotheism wins. There can only be one set of gods in a company. And the gods in the media companies are the journalists or the actors. They're the creative people. And they're the ones who see themselves as the center of the universe. And they don't understand that if no one can see them or read them or hear them, there isn't going to be a business. But as a result, they tend to look down on technologists. They don't pay them well. They don't cooperate well in building product. Everything that fails is a technology problem. So, while there's some very good people, the innovation in media often comes from the outside in technology. It doesn't, they don't. It's a conflict that's still going on. I mean, companies I know today, they're still having this battle. The New York Times today, however, has learned its lesson. It has more developers than journalists. The Washington Post has more developers than journalists. Goldman Sachs has more developers than investment bankers. I mean, every company today is a technology company. And if you don't believe that, then you're going to be in trouble. Maybe not tomorrow. But if you look at where AI is coming and what AI is going to do tomorrow or the day after tomorrow, unfortunately, that's true. I mean, every business is just an information system. And so information technology affects business.
Interesting. So, you stayed with Time Warner a few years.
Yeah.
And
2002.
Your career paid you well enough to become independent.
Well,
and work with boards.
It left. I mean, boards paid money, and I had some consulting assignments, and I was pretty busy. I tried a startup, but we ended up facing off against Apple, and you can't win. I mean, it's not. We were underfunded, and it's a long story. People can buy the book and read it. But I was busy. I was chairman of Opera Software. I worked as an advisor for 11 years to Daily Mail in London. I advised 15 years Naspers, which owns a third of Tencent, 35% of Tencent still. I'm still in contact with all of these people. That's
a Chinese company, correct?
Well, Tencent is. Naspers is South African.
Oh, okay.
And they bought Tencent, and I was there. Visited Tencent when they were a walk-up of about 30 people off of a back street in Shenzhen, and today they have 2 60-story towers in Shenzhen. So it's it's an amazing internet. It's the same as Amazon or Google or but we don't cover it because we don't pay attention.
So
what is your perspective about AI?
Well, AI will transform the world. It will make the world more divided, more unequal, and more fragile. But it isn't. I don't see it as an existential threat to humankind. I mean, the biggest risk, I think, is that our culture has become answer seeking rather than problem solving. And AI is going to make it just so much easier to be answer seeking. I mean, if you go to, whether it goes to ChatGPT or Claude from Anthropic, or Sage or Llama 2 from Meta. I mean, you get very good answers. I mean, if you see the results, you know, it passes bar exams, it passes medical exams, it passes MBA exams. Panels have said that the answers from these LLMs on average are better than the ones human doctors give. So, you know, I mean, it's going to have enormous effect, but, you know, there's a lot of AI. And just as there are lots of humans, every AI is trained differently. So they're not going to give you all the same answer. They give you quite different answers sometimes. And they have to be trained by the same content in the same exact order with the same exact hints to give the same answers. And so they're going to be just like human beings. There are a lot of smart people. You put them in a room, they don't give you the same answer to a question, and AI isn't either. But the one thing that humans can do that AI cannot is build trust. And ultimately, humans' competitive advantage is we know how to collaborate and we know how to build trust. And we build trust through a lot of ways that aren't just words. There's a lot of body language and interaction that's important as well. So, you know, I think it's critically important. I think, you know, Sam Altman wants you to regulate it. That is, please create barriers to entry so I have no more new competitors. And China isn't going to regulate it, so China's going to go. And, you know, it's going to transform the world. I mean, computer scientists talk a lot about abstraction layer. And that is, I hide the rest of the technology down here, and I put an abstraction layer on the top, and now you only talk to the abstraction layer. And ultimately, AI will become the abstraction layer. And as consumers, as employees, we're going to talk to AI. And if we need a spreadsheet, it'll build it. If we want to analyze it, it'll analyze it. And so it will.
But you still have to look at the answer, and maybe it's like that add-on of the econometric models, that there'll be an econometric model that'll give you the answer, and then there was an add-on. Maybe the AI will be giving you the what?
So I mean, you know,
well, you said there are different ones, so
yeah,
somebody will have to.
There's two things about AI, about the LLMs. One is they make stuff up, and the second is they lie with abandon. And you know, so that if it gives you an answer, it could be complete lying. I mean, it wants to please you, and it gives you the best answer it can think of. And if that answer is a 0.1% probability of being right, but it's the best answer they have, it gives it to you as complete certainty. So, you know, it again gets back to trust. And the way we build up trust is very complicated. The way humans, and we've evolved this, you know, over, you know, tens of thousands, hundreds of thousands of years, maybe. But if you want to go fight, you want to go out and challenge deadly animals, it's very important that you build up trust. And again, it is the ultimate capability of humans, is that, yes, you see animals cooperating, but we can get 1 million people working on a project. We can put people together, but to get people to cooperate, you need trust. You need to trust the people giving you, you know, direction. You need to trust the information you're getting back. And if you don't have trust, I don't know how you're going to do it. So, you know, I don't, you know, maybe they're going to figure out a way to, you know, a future generation of AI can go do that. But I don't see
well,
the.
you know, one thing that strikes me is that when we had the initial computer revolution and microcomputers became very broad-based, and so Robert Solow made this comment that he sees computers and technology everywhere, but in the productivity statistics. And over time, obviously, a lot of productivity did happen, but I'm a little skeptical that it's going to happen quite as quickly as people seem to say.
Well, I mean,
based on what's happened over many other technological revolutions.
I mean, I think you have to go back in part to Harvey Levinstein, right? Who was a professor when we were there. And, when he studied, he said, where are the monopoly returns? And he found that there weren't any. That the companies with monopolies paid back to the shareholders what they had to pay back to justify the stock price, but they spent the rest on themselves. And I think a lot of the productivity benefits that accrued ended up being spent internally, and people got easier jobs and companies didn't do it. I mean, all of Silicon Valley certainly is looking at Elon Musk, who got rid of 80% of the employees at Twitter, and the company's still running. And, it sort of is a wake-up call that maybe you had a lot of people who weren't really all that productive that you were paying.
But that wasn't because of AI, was it?
No, but maybe technology allowed them to build up jobs that they no longer needed, and without a lot of down discipline, they didn't get rid of those jobs. I don't know. I mean, I just think that finding meaningful work is going to be very hard going forward. I mean, AI takes away a lot of what made jobs interesting, and you just become a cog. And what we've learned is that people don't want the cog jobs anymore. And that's why you see the people struggling.
Well, I work on trying to expand apprenticeship. And the reason is that companies do want skilled workers in many fields. And as Tyler Cowen just said, that it's going to drive up the wages of carpenters. That is, a lot of jobs will still be around that do require physical things.
But
so,
even carpentry, if my nephew's a carpenter, the skilled things that they did, some of that can be 3D printed. And the problem is the construction companies know how to do it. You can 3D print the joint. And then all you have to do is have a laborer stick boards in. So you don't need a skilled carpenter. You need somebody who can stick boards into a hole. But you have to get the architects and the planning commissions and the building standards to accept that as an acceptable form of construction. And so that made, the delay isn't tech. The tech is there. The question is, when are the governmental systems going to allow you to build a house that way? Because you can 3D print all this stuff. But the problem is getting the specifications to accept 3D printed joints and parts. So it's, but I agree. I mean, plumber, yes, they're skilled trades, and we're going to need those people, and we're going to need probably more of them. But, we're looking right now at where do we get the people to do the Inflation Reduction Act, infrastructure expansion. We don't have enough skilled workers.
they're not there.
Not there. They just don't exist. So, but I mean,
But I do think that it will be enhancing. If it's productivity enhancing, it will be income enhancing. At least that's what we've seen. That's what we've seen over the years.
you hope so, but I mean, certainly, the number of good software people in the world is very limited. I subscribe to the belief that the number of truly A+ programmers is of the order of 10,000 in the entire world.
Wow.
And the productivity of these people is 20 times
Stratospheric
of the average, right? And if you've met these people and you understand it, and most great software ends up being written. Robert Scoble is a columnist that's well known in the tech field and been around a while. He just tweeted out that he went to SpaceX and he wanted to meet the software team that built the software that sends a rocket up and then lands it back on the launch pad. And they said, well, it was one guy. And he said, well, what do you mean it was one guy? And they go, it was one guy. I mean, there's too much information had to pass. So it was better to get just one genius to go write it. So one person wrote that software. And there just aren't a lot of these people around. And, probably more than half of them, maybe 2/3 of them, work in the Magnificent Seven, right? They work in Google, Microsoft, Meta, Amazon. I mean, and those companies are willing to pay, compensation that is beyond the ability of any normal company to pay. I mean, I think that the future of companies is going to resemble professional sports teams. And you're going to have players and you're going to have employees. But the advantage of a football team is it is clear who the players are. It's clear what their skills are. Everything is obvious. And the pro sports teams know how to handle compensation differences that are enormous, right? I mean, you have a player making $100 million and you have somebody who is making 40,000 as a janitor, but that in somehow or other is acceptable. But software people are going to be just like players, but you can't tell that. Most people aren't going to be able to evaluate that this person is really that good. And that is going to, and so it's very hard for a company with, I think large union labor in particular to do it.
Can't you give them an assignment and see how well they do?
Well, yeah, but how do the employees know that? It's that the employees see the players and understand it's okay that they make all that money because they do something they can't do. But how do you solve that problem with the developers and the engineers? And I haven't seen an easy answer to that. I mean, there are engineers at Google that make multiple millions of dollars a year as a developer. And you couldn't have that situation, I think, and make it exist inside the HR system of GM or Ford or Stellantis. I mean, I just don't know how you do that.
So you're still on boards and so on? What's the most interesting company that you're working with today?
The most interesting company right now is probably a small startup called Sonera, but I'm not on the board there. I'm an advisor. I've been a longtime director of a company called Live Intent, and we put ads in newsletters in email. And that is an incredibly technology challenging task because you only have 200 milliseconds to do it. And so you got to figure out in 200 milliseconds how to select an ad and then display it and get it there. That's, it's a very challenging thing. It's 200 milliseconds is not a lot of time, but it's, and it's advertising and it's tech and media. So it's something I like a lot. I'm on a stealth startup that I can't talk about that's doing something really interesting. And I'm advising, an AI company and, learning a lot about AI by doing that. I mean, I found that the most valuable thing about being on a board or an advisor is you get to keep your brain alive and learn. And you don't learn until you face challenges. You don't learn until you get faced with, you got to make a decision. And what are the real trade-offs and where do they go? And that's how you learn. And so I want to keep doing it because that's how I learn.
Well, that keeps, that's why both Svi and I say don't retire. And I'm certainly still active.
And that's why we're doing this.
We're doing this among other things, and we're learning from each person. And I think you'll find a few interesting people that we've interviewed. Bill
I'm looking at your list.
So you certainly are high on that list. And well, like you said, there are only 10,000 great programmers, but there's only 33 people that have been interviewed for Ideas and Lives. So
okay, well that puts me in a very select class. I know.
You're in a select.
That's right.
Select group. Select group.
Well, thank you.
Well, um,
The world
so,
is changing.
go
I mean,
ahead.
I mean, there is when Galbraith viewed the world, technology change was all around him, but technology change was hardware. Now technology change is software. So a single person can change the world, right? Google Maps was a single programmer at Google. The
Really?
underlying technology was invented by Alex St. John at Microsoft. I mean, single individuals bring about enormous amounts of change. And that's what software allows, because again, as you create abstraction layers, you get to play up here and you can implement the idea up here. You've got a whole stack of technology that you can lever to go get it done. And that's why change is going to continue and continue and continue and continue. And I mean, you know, one guy invented Bitcoin. You know, they're probably a few hundred people at most that can actually build the software to go run a blockchain. But those few hundreds of people end up leveraging enormous change in the world as many things, you know, migrate to blockchains. So it's just not going to stop. And AI is going to just, you know, AI doubles the productivity of a great programmer, maybe triples it. So it leverages the great people more than it does the mediocre people. I mean, there's no doubt about that. You know, you can
Wow.
you can AI. I mean, ChatGPT will write code for you, and you tell it what you want the app to do, and it'll build an iPhone app for you. I mean, you know, it's leverage. It's huge leverage.
Well, you know, in finance and in the financial system, trust is fundamental. And if you can't trust ChatGPT and AI systems, that I think creates a real problem.
But you know, I mean, what do smart humans do? They go and ask 5 to 10 other people what they should do, and they use that to cross-check and see, you know, what it is. So you can go ask 10 AIs. I mean, look, I mean, you can feed 100,000 characters to Claude. So you could take an annual report and feed it to Claude and say, what do you think of this? What should I worry about? And it'll tell you, and it'll do a pretty good job of that. But, you know, I can't trust that it's gotten the right answer, but I can't trust a human that he's given me the right answer. But if you want to go build a network of these AIs, each running different things, I just don't know how you build the trust around them. You can say, well, they all have a common creator. And I mean, you get into, I mean, this is the problem that's going to get addressed. The real challenge for AI is copyright. ChatGPT just went and stole all the content to train itself. And it just took the list of anybody who said I can be searched and then pretended it was a search engine and read it. But the people who got read are going, no, you got to pay me. And nobody is prepared to pay. But all the copyright owners are going like, you can't train yourself on my content unless you agree to pay me. And so that's the big obstacle practical obstacle in the way of AI. And the companies with a lot of intellectual property all want to have their own AI that has their proprietary knowledge in it. And they don't want anybody else to have that knowledge. And that's going to be the war of the next 2 years, 3 years, is figuring out who gets paid for what. And there are people who argue that Congress, or whatever body would do it, it should just declare that it's in the national interest for AI to be able to train any copyrighted content without compensation. And there is I won't say that there is a group that holds that as a fundamental principle. And then there's another group that says over my dead body. And it is going to be the battle royal because it's very important. And unfortunately, our adversaries are not going to respect copyright, especially American copyright on American content. So to the extent to which they can steal that, they can train their AI on it. And so a US AI may be inferior because we're not allowing that. So there is a national security issue that comes in on this question, which, will make it very interesting.
Lots to think about. Well, Bill, it's been fascinating.
Thank you.
Really, we really
Thank
appreciate
you.
it. And we really appreciate you going through and had a really interesting career. You came along at the right time with learning programs and programming and concepts and how it fits in with economics and business. And, we're just in awe of your success and of your thinking. And thank you so much for joining.
Thank you.
But
Thanks.
we have one way of saying goodbye. See?
Sei gesund.
We say sei gesund,
Be
Yiddish for be well.
well.